I now want to look at the idea of a histogram. A histogram is very similar to a bar graph, but it's made for numerical data, whereas bar graphs are categorical data. In addition, it's a way to graph a frequency distribution. A histogram is going to use vertical bars of various heights to represent the frequencies of the classes. Unlike a bar graph, the vertical bars of a histogram should be touching, unless we have a frequency of one class that's equal to 0. In order to create a histogram, we're going to start by drawing and labeling our axes. The x-axis is going to contain the class boundaries. The y-axis is going to contain the frequency or the relative frequencies. We then draw vertical bars to represent the frequency in each class. Let's consider this frequency distribution, which contains the ages of the first 45 presidents at the time of their inauguration. And we want the appropriate histogram. We'll start by drawing our axes. I have my y-axis and my x-axis. Along the x-axis, I need the class boundaries, which are 40.5, 45.5, 50.5, 55.5, 60.5, 65.5, and 70.5. The y-axis is going to contain frequency. For that, I'll go ahead and count by twos. Here's 2, 4, 6, 8, 10, 12, 14, and 16. We then draw bars. So our first class has a frequency of 2, so we'll draw a bar at a height of 2. The next one has a frequency of 8. The third one will go up to 16. The next one will have a height of 9. After that, we have a height of 7 and of 3. Technically, all of your bars should be equal width, but since I did this by hand, we see a little bit of error here. But we do have our frequency distribution. When we look at a histogram, there are several important factors to consider. The first is the spread. How much data does it cover? Essentially looking at the biggest and the smallest values and the distance between them. We also want to consider the center and if there might be any outliers, if there might be any really high or really low values. And we'll discuss more about the center of a histogram in a future video. The third thing we'll want to consider is shape. Histogram distributions are very rarely perfectly shaped, so it's not necessary to have an exact shape, but instead we want to identify patterns. And there are several different patterns that may occur. Now I'll look at a few of the more common ones. The first shape I want to consider is symmetric, which looks about like this. The main thing is that it has the same on the right and the left. And it goes down, so essentially we have the peak in the center, and then the right and the left are the same. Sometimes this is called normal or the bell curve. We also have this one, which is called skewed left. And this distribution has a peak on the right and this tail on the left. And this is where it gets its name, is because the tail is on the left side. Similarly, we can have right skewed. In this case, the peak is on the left and my tail is on the right. So it is common to mess up left and right skewed because a lot of students want to think about where the peak is, but instead this distribution in its name is referring to where the tail is. The last one I will consider is the uniform distribution. This one has everything roughly the same height.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.